All right, hey, how we doing? I'm going to talk to you a little bit today about this new product from CTNEWMAN Engineering. It's a vertical tubing bender. It's great for motorcycle related things, handlebars, frames, things like that. I've been using a vertical bender for probably about 10 years now. I've made a lot of modifications to the bender that I started with, and this new design here pretty much incorporates all of those changes that I've made over the years. So let me just go over a couple of the features here. First off, it's a vertical bender. Why is a vertical bender good? A vertical bender is good because you can, instead of using the degree wheel on a horizontal bender, you can use a digital angle finder. And so you can measure the angle of your stock and then measure the angle of your bend. You can do this while you're bending, and after you release pressure and your spring back is released, you can now calculate the difference. That's huge, especially when you're doing things with materials that have a lot of spring back, like stainless, because it's not always terribly consistent. Second, it's on wheels. It's not bolted to the floor. So when you're done using it, you can push it in a corner. When you need it again, you can drag it out and use it anywhere in your shop. It can bend 100 degrees with one move without resetting any of these drive pins. You can get 100 degrees of rotation, so you'll easily get a 90-degree bend after spring back. Some of the things that I've done, a lot of my handlebar builds and bike builds tend to have really tight radiuses. And so what I've done is included with the bender is a 1 inch by 1.9 centerline radius die set. And what that allows you to do is make really tight radius dies, and also with the device that I have to hold it, you can get your bends extremely close together. You can get as little as 1 inch between your two bends. Another feature is it can handle a 22-inch diameter die. So often I've made wood dies and things like that for my benders, and the limitation was generally this arm. And so I've given a lot of extra clearance here so you can do some really large diameter bends. If you want to bend some things other than with this one die, you can use any standard Pro Tools dies. They mount in here as well with the standard shackle block and bottom block and bending die. It'll take Pro Tools dies up to 2 inches in capacity. The construction of this, it's double layer 3/8 for a total thickness of 3/4 of an inch. That's thicker than any other bender that I'm aware of on the market, at least that's popular within the motorcycle world. It comes with a hydraulic ram already attached. Well, not attached. It's actually a U-assemble kit. So this comes on a pallet flat pack with raw steel, and it requires welding to put together, and then you can paint it like this if you want. Anyway, so it comes with a hydraulic ram. It does not come with the power pack to drive that ram, and the reason being because there's a huge amount of different options there, but you can do something very basic. This is just an Amazon air over hydraulic unit. It runs about $125. You can do a manual hand pump. You can do an electric hydraulic if you don't have an air compressor. There are a lot of options. There's a lot of different price points and quality, so I'm leaving the power pack up to you. A couple little other things. It has a work table, which is extremely handy. It will hold your wrenches, it'll hold your clamps, it'll hold dies, hammers, anything that you find that you might need while you're working on the bender. And on the back side here is a rack to hold up to 4 other dies. So you can keep everything in one place. All right, now I'm just gonna go over some of the features of the 1.9 CLR die, which is different than some of the other dies on the market, obviously because it's the smallest radius that I'm aware of. And so I'm just gonna change some things around and then we'll jump right back. This is a set of 6-bend handlebars that I bent up on this bender this morning. I used the CAD program that's included with the bender to figure out the dimensions of this, all the rotations, the bends, the feeds, and bent these up, and they came out pretty good. I just wanted to talk to you about some of the features of this super tight radius die. One, we've got our drive pin located up out of the way. That allows for more clearance down in here when you're doing the bends. The shackle that holds the bends goes in on here. You can install the pin here. You can install the pin in here if you want to hold it really closely. And that just gives you the really tight bend-to-bend numbers that you can't get with other benders. One thing to note though with this very small radius die is you will get a little bit of necking on the inside of your bends. It's not terrible. Usually you can blend it out just by cleaning it up here and here a little bit, and you won't even notice it with the naked eye. But numerically, we're losing around 7% on this 120 wall, 1-inch stainless steel. It is welded tube, not seamless, so that usually crushes a little bit worse. But so worst case scenario, I've lost about a 1/16 of an inch on the cross section here. But you know, it really isn't that noticeable, and like I said, you can pretty much blend it out and not notice it at all. Okay, I'm going to show you how the vertical bender actually works and what is really great about it. So I've already gone ahead and put a approximately 45-degree angle bend in my tube, but I haven't done anything else. So the first thing that I'm going to do is set my feed. And in order to set my feed, I'm going to come here and I've got a 1-inch shaft collar, which is included, and I'm going to slide that up to set my feed. So the feed distance is going to be the distance between the bends. So I'm going to go for about 2 inches here, and I'm just going to tighten that down. All right, next, I'm going to take my handy dandy clamp. This is just a vice grip with an angle and a flat plate welded to it. And I'm going to clamp this on the tube. The orientation doesn't really matter. And I'm going to take my digital angle finder and I'm going to set that on there. And I'm going to turn it on and zero it out. Okay, now I'm going to pull up on this to release it and push it forward. And for the time being, I'm just going to let this hang. And so now I'm going to come in here and I'm going to reset my die. And in order to reset the die, we just got to line a few things up. You put your backing plate underneath here and slide this pin through like so. Okay, now I'm going to look at my angle finder and I am going to set this to a 90-degree angle. And what that'll allow us to do is then we'll know that our bends are 90 degrees apart. And it could be 180, it could be whatever you want. And note that I've slid it forward till the shaft collar bottoms out on this die block. And what that means is that I've fed 2 inches into the machine. So the last thing I need to do is put this pin through here, and we'll just line it up by adjusting that a little bit. And the last thing we have to do is loosen this shaft collar. Now, this whole time I've been keeping downward pressure on the back of this stock right here, and that just kind of locks everything in. So once the shaft collar is loose, I can slide that back out of the way, and then I'm going to start my bend here. And so once I've got some of the bend engaged, I'm going to take my angle finder off of here, or if you have a second one, it's really great. And I'm going to put it on here. And what I'm going to do is I'm going to calibrate it. And that'll zero it out. And then I can indicate off of the bottom of this tube right here. And it's going to be hard to see on camera, but I can see it. And what I can do is now I'm going to be able to read my angle that I'm bending. So let's say that we're going for a 30-degree angle. Sorry about the air compressor kicking on, but there's nothing we can do about it. We're going to go for a 30-degree angle here. Just from my experience, I know that 30 degrees will get around 2 degrees of spring back. And so I bent it to about 32 degrees here. And so what I'm going to do is release. Once this pin is loose, I know that there's no tension on this system. So I can come over here and just to check, I'm going to zero my calibration out, put this back on here, and we are almost perfectly at 30 degrees. So now we've made one bend in respect with relation to another bend. We know the difference in the angle clock between them, and you would just go on and continue to bend and bend and bend with your however you want to bend it. And you can do that based on the CAD programs that I provide or your own design. So thanks, good luck.